Welcome to an NJ Spotlight Conference, Building a Sustainable Infrastructure After Superstorm Sandy. This program took place on Friday, June 14, 2013 in Trenton, New Jersey. This program is brought to you by New Jersey American Water, AEA, Energenic, PSE&G, Veolia Energy, and Clean Energy Ventures. In this program, Panel 3, Distributed Generation, the Wave of the Future. The panelists are Geroyd Foley, New Jersey Director of the Mid-Atlantic Clean Energy Application Center of the U.S. Department of Energy. Pamela Frank, Vice President of Gable Associates, LLC, a consulting firm. Bob Kudrick, Manager of Business Development for Combined Heat and Power, Clean Energy Ventures, a subsidiary of New Jersey Resources. Jeff Perry, Chief Development Officer, Veolia Energy North America, and Stephen Poniatowicz, Senior Vice President and Chief Operating Officer of Marina Energy, a subsidiary of South Jersey Industries. Moderating the panel is Tom Johnson, Energy and Environment Editor for NJ Spotlight.
This is our third panel, and it's on distributed generation, a topic that's gotten a lot of focus in the wake of Sandy. And there's a lot of moving parts on the issue on both the legislative front and the regulatory front. And we got a great group of panelists to tell you guys what's happening and what needs to happen. And first off, we'll have Geroyd Foley, the New Jersey Director of the Mid-Atlantic Clean Energy Application Center. Geroyd?
Thank you, Tom, and appreciate you guys sticking around through the bitter end here. I guess the first thing, this is the panel here, is distributed generation, the wave of the future. So I'll take a little issue with that. I think distributed generation is clearly here and now, and it's not really the wave of the future. Distributed generation incorporates quite a number of different technologies, including renewable energy such as PV, wind, biomass, and fossil fuel generation also, such as natural gas-fired combined heat and power, diesel emergency, and peak shaving generators. The wave of the future from our perspective, from the DG perspective, is really policy development. And policy development with the goal of extracting the benefits offered by distributed generation on behalf of the ratepayer and society. Energy policy at its core has three basic objectives. It's to provide cost-effective, clean, and reliable energy. Superstorm Sandy has clearly pushed reliability to the forefront with a focus on grid-independent, long-term reliability as opposed to short-term reliability, which is sort of what we were more used to in the past. And from this perspective, combined heat and power, where it applies, has become clearly a go-to solution. We've recently seen the proposed budget by the Board of Public Utilities move close to $100 million towards combined heat and power. Just to acquaint everybody with combined heat and power, it's essentially the sequential production of power and heat from a single fuel. Its efficiencies exceed that of grid-based systems, and because of its lower fossil fuel use and the fact that it normally runs on natural gas, it's also considerably cleaner than grid-based systems. In addition, since it's located at or close to the point of use, additional transmission and distribution systems are not required to get the power to the load. It's dispatchable and can be configured for grid-independent long-term power supply in emergency situations such as another Superstorm Sandy. Governor Florio mentioned this earlier on, and this was kind of one of the points that I wanted to make here, is policy really needs to be informed. And while I've talked about some of the benefits and applications of distributed generation and combined heat and power, it's not free. We need to account for the societal benefits of distributed generation, including combined heat and power, in order to A, understand the benefits in tangible terms, and B, understand if and how much society should contribute to gain these benefits. The benefits include emission reduction, which leads to healthcare cost reduction. That's a societal benefit. Offset of transmission distribution, which is a reduction in cost to ratepayers. Maintain business competitiveness by lowering energy rates for businesses. That allows us to retain more jobs in the state of New Jersey, and the societal benefit there is to retain tax income. Provide a place of refuge in a grid outage is a pretty obvious one that we've all probably experienced significant outages in the wake of Superstorm Sandy. Who wouldn't have paid to have a place of refuge where you could go in, have a hot meal, have a shower, see some electricity in action? Maintain production and employment in these outages is also a societal benefit, and again, that goes back to maintaining production and the tax revenues that are derived not just from the business taxes, but also from the employees that are able to continue working. And obviously maintaining critical infrastructure such as hospitals, which is a life safety issue, and correctional facilities, a public order issue. What we found in the discussions that we've been having is that, even in the light of Superstorm Sandy, the discussion on benefits is very much around the only visible attribute, which is energy costs. And while the societal benefits are much sought after, they're not currently in the equation. Using CHP as an example, we understand the benefits derived from CHP in a non-grid outage scenario, which are many. But if we convert that to be able to maintain the facility in operation in the event of a long-term outage, there are significant additional benefits. What we need to recognize is that while the cost of traditional CHP without the grid islanding capability is substantial, the cost of making facilities grid independent can be a significant addition to the costs of that system. And what we need to understand is that the benefits offered by traditional CHP for private entities and allow that facility to reduce its energy costs, obviously those benefits are derived to the owner, but also based on the taxable income that may be available from a grid-independent system, those benefits are also derived to society. In the case of applying CHP at public facilities and critical infrastructure facilities, those benefits in terms of that additional cost to make the facility grid-independent are predominantly all societal benefits. Policymakers and stakeholders need to apportion costs and benefits equitably in order to enable the development of distributed generation and CHP, or otherwise it simply won't happen. I think we're doing a good job in New Jersey, and we are moving down the right path towards understanding how all this works. It's complicated with a lot of divergent opinions, and there's been pretty robust discussion over this since Superstorm Sandy on these issues. We are working on how to achieve the right mix of technologies and the role distributed generation can play, but we can only get there if all beneficiaries contribute. We need to agree on the benefits and what, if any, value they have and to whom. Then we need to implement long-term policies that will get us where we need to be by the time the next major superstorm hits. Thank you.
Thank you, Geroid. Pam Franks, the Vice President of Gable Associates. She's had 14 years of experience in the energy and renewable energy industry. Pam?
Thanks, Tom. Thanks, everybody, for sticking here on a Friday. So my background, I work with Gable Associates. We're an energy, environment, and public utility consulting firm. Prior to that, I spent about 10 years in solar, and my background's actually public health. I did a master's at Rutgers, and I've always been very interested in the crossings between sort of energy and public health and how they intersect. And I guess Sandy offers some rather stark illustrations of this. I have an 11-year-old and a 14-year-old. The 11-year-old gets up every morning and watches the Weather Channel. That's now his standard mode of operation. And routinely asks me questions like, Mom, are we going to get a tornado here in New Jersey? Because there were tornado warnings last week. So there's definitely been a change in the weather. I won't comment on climate change right now, but it's something that my kids are keenly aware of, and I think it's kind of interesting in terms of how the next generation is going to deal with these issues and actually look at this generation for what we did or didn't do. we see really quickly, actually, an event like Sandy, and I guess it's a focus moment for us, because in an instant, and again with sort of a public health hat on for the moment, you see how quickly our water systems, our communication systems, our energy systems can degrade, and suddenly we look like a third world country with third world problems. Contaminated water, I mean, things can go from bad to catastrophe very quickly. And I think as public education goes, there's nothing like some really severe weather to wake people up and really educate them in terms of the meaning of a good, sound infrastructure. So while we like to talk a lot about education, and we certainly need to educate folks, I think the weather's been very helpful in this regard, and we need to take every opportunity to capitalize on this while we've got folks' attention. About why we need to continue working towards an infrastructure that's going to be robust and resilient now and into the future. About 10 years ago, I was part of discussions regarding the renewable portfolio standard, which is the carve-out we have in the state for renewable resources, and carving out a piece of that for solar. And it was very interesting discussions 10 years ago. There was a long list of benefits of solar being discussed at that point, and some really good reasons why our policymakers at that time thought it made a lot of sense to do a carve-out for solar. And when they listed sort of the good reasons for solar, you know, sort of down at the bottom of the list was this thing called, oh, and it's distributed. And most people didn't know what that meant. You'd go out in public and try to talk about this, but when we said distributed, pretty much what we were focusing on was the efficiency piece. You know, you're basically generating electricity close to where you use it, and that makes sense, and people thought, yep, that makes sense. Today we talk about DG, and now it's seen through this prism of Sandy, I think, and we really start to think about distributed generation in terms of the redundancy it can offer to the overall system. And you hear words like redundancy, you hear words like islanding, and suddenly distributed generation and the 20,000 solar systems that we've got up in the state start to look a little different in the minds of people, and people start to think, well, maybe these can kind of help us in times of blackouts or grid failures. It was a surprise to some people in the state when we went through Sandy that a lot of these systems, the solar ones, I mean, CHP's been around for a while, as we'll hear, but solar was very visible to people, and it was a surprise for many people in the state that these systems didn't keep on generating. Those of us in the industry understood why that was. They were never meant to function like that. But today, there's a very new emphasis and a new conversation taking place where people say, wait a second, we can take these distributed resources that we have, the CHP, the solar, other technologies, potentially storage, which can really help, and we can now think about isolating them, islanding them, creating redundancies. And in order to do that, of course, we need additional incentive. We need additional resource to be able to do that. The experience I had in my town, I live in Lawrenceville, during Sandy was interesting in that the high school remained with power. And the town very quickly decided to open that facility and allow the residents to come in, take showers, serve food, use electricity, computers. Obviously was a very big benefit to the public. And I think these types of resources and these types of facilities are the sorts of things the public supports the idea of having places they know they can rely on in times of outage. I think as Stephanie Brand said earlier, it's unrealistic to expect that we're going to be able to create a perfect system. We don't have the money for it. We don't have the resources for it. We have to minimize the outages when they happen and reduce the time to get back up. But in the meantime, what do we do to keep people connected, fed, warm, safe? We've got to create these islands of reliability, and I think that's why there's been a renewed emphasis on distributed generation, because with some additional incentive, I think they can offer those types of resources in the system. I guess I also want to just point out there's been so much talk today about Sandy with regard to resiliency and the need to create redundancy in the system, but we also should not forget, Sandy was a big wake-up, it was a dramatic event. Well, we also have this threat, this continuing threat of cyber terrorism. And doing everything we can to create redundancy and resilience in the system also helps not just to protect against severe weather events, but to also protect against cyber terrorism events. that's something the utilities are involved with every day and dealing with every day, but we do get sort of more bang for the buck than just, creating safeguards against extreme weather events. In terms of what the state has to grapple with, and I want to talk a little bit about CHP for a second, because that's gotten a lot of attention. I think that the state has a lot on its plate in terms of having to look comprehensively at all of what is required across infrastructure, water, in terms of transportation, in terms of energy, and really come up with a way to prioritize. I mean, it's like policy triage, I think. And it's we're already a little too late on this, but we've got to recognize both the public and the private benefits of these distributed technologies, and be able to prioritize in such a fashion that when we use public dollars to help incent them, we make sure we're doing it in a way that makes the most sense, it's the most equitable, it's going to give us the most bang for the buck. Now, there's $100 million, I know that figure's been thrown around a lot about CHP, and one thing I want to emphasize, in our firm we see a lot of CHP projects. We've done many over the years, and there's a lot of interest in this area. And there's, I think as Stephanie Brandt had said before, we can't just expect throwing money at this is going to solve it, because the thing about CHP and these projects, and these gentlemen can probably speak to it better than I can, but just some very real-world considerations. A school might sound like a great place, or a public facility like a school might sound like a great place that we want to create sort of an island of reliability, if you will. But if you look at a typical school, it doesn't typically have the power factor, or to speak in sort of a layman's terms, if you look at how much heat a school requires and when they require it, if you look at how much electricity a school uses and when they use it, it doesn't exactly match up perfectly and optimally for a CHP project. And those of you who live in this world will understand that. And so if we decide as a state that we want to see certain types of facilities in our list of priorities, we look at hospitals where vulnerable populations are housed, we look at water treatment facilities, we look at potentially public buildings in municipalities, we need to be smart about what our expectations are about what those facilities can provide, and the incentive required may be perhaps more than what we think it should be, but that's because a lot of these facilities may not be optimal. So we can't just rely on the market to deliver the solutions we want. We have to sort of craft and target where we want to see them happen, and then have those incentives directed accordingly. I think last, I do want to just mention, we've just been recently involved in a solar procurement, a successful solar procurement, where the school went out and did a backup as well. And so they'll have a system, a solar system at their facility that's actually has a battery backup, and that battery is going to be fueled by solar, so nobody has to get gas or diesel to fuel a generator, which is an interesting application. These things are starting to be commercially available. That is, additional cost for someone, and there's some commercial solutions that are starting to address that. Facilities also want to see things like islanding, and that will cost more money. That does require more technical resource and more capital resource to make islanding happen. I think in the end, the state has to deal with, again, as I said, this policy triage, and the folks on the ground also have to deal with a sort of triage in a way of exactly what types of facilities do they want to keep online, and what services in those facilities do they want to offer. When we deal with extreme events, we typically have scarce resources, and it's really all about prioritization. So it's going to start at the state level, but I think it's also going to trickle down to the people on the ground in the municipalities, the rescue workers, and to be really smart about how we use scarce resources. Thanks.
Thanks, Pam. Bob Kudrick is Manager of Business Development for Combined Heat and Power for Clean Energy Ventures, a subsidiary of New Jersey Resources. Bob?
Thank you, Tom. Good afternoon. I'd like to just share an observation about how we saw a program enable a technology a revelation about CHP, and then finally potentially the solution to help that move along. We've witnessed over the last several years how the financial support for the solar market has driven almost 22,000 installations with an installed capacity of almost 1,100 megawatts. For a technology that began at a cost somewhere north of $7,500 a kW. It was the incentive program that enabled these installations. And those incentive programs helped to reduce the cost of that technology over time. At New Jersey Resources, we invested ourselves over $180 million in that marketplace. And we strongly believe in the long-term benefits provided by these projects. So how can we create similar interest and monetize that same benefit for the CHP market to meet the 1,500 megawatt goal? I appreciate you staying, and here's the revelation. It hit me about 5 years ago. CHP is not sexy. Nobody ever asks to see it because it's a technology that lives in the bowels of a building. It's usually down in the basement or somewhere out back. The only time people really truly care about it is when someone strikes a utility pole and we lose power. Maybe the air conditioner goes off. I have never seen in my 20 years in the energy industry people take such an interest in DG as they have since the storm that we just had this past year. So how do we incentivize a technology that can keep our critical infrastructure operating in a time of crisis, help customers use energy more efficiently, and save money at the same time? It's a common thread to the conversations that have been said by a lot of the people on the panels today, and I'm going to echo that. First, looking at the 2014 BPU budget containing a significant bucket of money there for the development of specifically for CHP. How can that can provide traditional benefits outlined earlier? Those benefits obviously keeping critical infrastructure operating. We do realize, though, that annual appropriations of this magnitude are not sustainable in the long term, and this is not an industry in need of technical development. CHP has been around for a long time, and the engine development has not progressed significantly over that time. So we do know that CHP is a mature industry where costs will rise in line with inflation. So where we saw in the solar industry a reduction in cost over time, that won't happen with this. We're going to follow the trends that you see in an automotive industry, because that's what the technology is based on. So there won't be the dramatic cost reductions. As the industry develops and regulatory barriers are removed, there will be some cost reductions, but the basic equipment, engineering, and interconnection and construction costs are well established. We believe that the portfolio standard, as proposed both by the BPU and the legislature, is an appropriate way to demonstrate the long-term commitment and the necessary incentives for these projects going forward. We need a portfolio standard that adjusts incentives and that is derived from competitive market forces. Allow the incentives to adjust as time goes on. It needs to be a mechanism that encourages development of cost-effective, highly qualified projects. If it doesn't run, it doesn't get paid. Let's face it, there are some facilities with very good electric and thermal base load in our state, but the mechanical systems may not have been ideally situated at the site. Buildings were added onto, and maybe it's not easy enough to bring the CHP in. With an incentive-based program that will be bid into, this will allow for these projects that may need a little bit more capital. The portfolio standard program would allow for these systems to be built at little or almost no cost to the customer. As I said, it's not sexy. The other item about this is that it is a long-term investment. They can be very capital intensive, and sometimes they compete inside the organization with other priorities. Many companies want a quicker return, and they have to justify this against other equipment updates that are being done at their facilities. Sometimes the customers don't have internal resources to be able to direct, evaluate, and then go out and build the CHP systems. So in those cases, companies have to look for development organizations like the folks on this panel who will be able to build, design, own, and operate those systems for them, and potentially just buy power at a lower reduced cost, and which would then also provide the customer with the backup that they need. So in closing, we believe that a portfolio standard is a viable path to help the state achieve their objective of 1,500 megawatts of CHP by 2020 that will help keep critical and other CHP customers operating and save money, and allow customers to operate when times that the grid is down. Thank you.
Thank you, Bob. Next up will be Jeff Perry. He's Chief Development Officer for Viola Energy North America. Jeff?
Thanks, Tom. Good afternoon. So let me first provide you a little context for my opening remarks. I'm going to spend just a second of my 5 minutes talking about Veolia Energy, give you some context. So we're a multinational company. We're focused on providing water, waste, and energy solutions. On the energy side, we operate over 800 districts around the world. We've developed, we operate and maintain about 5,000 megawatts of combined heat and power. We own the largest number of district energy systems in the U.S., including the one here in Trenton that's serving this building right now. We also develop, operate, and maintain small-scale CHP in New Jersey and throughout the U.S. So my comments clearly are going to focus on CHP. The topic of this session, of course, is distributed generation, the wave of the future. Well, neither CHP nor distributed generation are novel concepts. CHP's been around for 100 years. The notion of distributed generation goes back at least to the time of generation planning. As to CHP, there's been a fairly recent recognition with a growing focus on greenhouse gas emissions that the efficiency provided by producing simultaneously heat or cooling, if you will, along with power generation is a great environmental benefit, and of course it is. But CHP is not new. It's just becoming a bit more visible. As Bob said, it's certainly not sexy. As to distributed generation, for years, utilities and power pools have cited and they've built central generation facilities in order to minimize the cost of transmission, to support existing transmission, and to minimize voltage concerns. Like CHP, there's nothing new about supporting reliability with generation. It's simply part of prudent planning. It was done because it was cheaper, more reliable in many instances for customers than building transmission. You simply built a generator, you put it in the right place, and it avoided an awful lot of transmission investment. To support local loads in times of stress, generators were, and they still are, often run out of economic merit order in order to provide voltage support, and they're compensated under reliability must-run contracts. So it's clearly understood that ratepayers are going to pay for reliability, either in the form of transmission or in the form of generation. The question is, and it should be, what's the best solution? What's the cheapest solution for that reliability? Integrated resource planning came along, many of us remember this, back in the 80s, and it introduced conservation and load management into the equation. So the key question then became, what's the cheapest way to ensure reliability? Is it transmission? Is it generation? Or is it demand response? There are clearly times when transmission is the best answer. There are clearly times when demand response is the best answer. But a well-articulated, comprehensive energy policy will also recognize that there's times when small-scale distributed generation is the answer as well. Distributed generation has a place environmentally, and in the case of CHP, which is a dispatchable or non-intermittent distributed generation solution, it has a place to ensure system resiliency as well. From an environmental point of view, CHP can displace older, less efficient generation from the grid. The efficiency of CHP is often far greater than the conventional non-renewable generating resources that are currently feeding the bulk transmission system. Generation in the form of cogeneration distributed also has a place in providing reliability in congested parts of the system. It will help to support the local grid. It will avoid the build-out of additional transmission. And as we all know, it can also provide reliability to critical facilities such as healthcare facilities or water treatment facilities. And in that way, It provides a very important societal benefit in the event of grid-wide outages such as we experienced during Superstorm Sandy. In addition to providing reliable electricity to an individual facility, in many instances, thermal output can feed campus environments with hot water for heating, or steam in the form of heating or process use, or even cooling, or it can provide cooling applications in general, thus reducing or producing, if you will, even more environmental benefits. Distributed generation is available today. So as Gerard said earlier, this is not a wave of the future. What is the wave and what we need to work on is a strong and well-articulated energy policy to help generate that real wave of the future. Sandy was devastating for New Jersey, no doubt about it. CHP provided an oasis during that storm. Numerous examples exist of campuses and buildings that rode out the storm. Rewiring and strengthening transmission and distribution infrastructure to withstand hurricane-force winds is prudent planning, period. Citing reliable, dependable, secure, island-capable generation near sites of critical loads, like hospitals, like wastewater treatment facilities, is also prudent planning. It's critical that we continue to identify and address barriers to entry for distributed generation, and to work collaboratively with the many important stakeholders, many of whom are here. Those stakeholders include commercial facilities managers, consumers, let's get them involved, DG providers, utilities, the BPU, and legislators. It's not a simple problem. All of us that have been in the energy industry know there's no simple answer to any problem. But I think what we need to do is we need to come up with a comprehensive, well thought out energy policy that at least considers and includes, where it's appropriate, distributed generation. And last, it's equally critical that we do it quickly. I find it funny, I was sitting here, I don't often get to these events anymore, but I've been doing them for years, and I was sitting here today trying to think of how many energy forums I've sat through in my career, and it's dozens. And every one of them, someone has said, now's the time, there's no more time. For 25 years I've been hearing that. It's always now, no question about it. But I think we're seeing some trends lately that make this even more important, and certainly we can point recently to Sandy. Thank you.
Thank you, Jeff. Finally, we have Stephen Punatowicz, I'm sorry, I mangled that, Senior Vice President and Chief Operating Officer of Marina Energy. Stephen.
Thank you. Good afternoon, everyone. Marina Energy is a subsidiary of South Jersey Industries. We basically develop, own, operate energy production facilities, and we've been around since 2000. Both thermal and CHP. We also have landfill gas to energy facilities and have invested heavily in solar in recent years. We are also 50% owner and participant in Energenic LLC, also a very active CHP developer, owner, and operator. Collectively, we have several facilities in the state of New Jersey. Most recent, our newest, is the Montclair CHP, which is going to be coming online the third quarter of this year. And we have several facilities in Atlantic City, 5 landfill gas facilities in the state, and 35 plus solar installations. I want to take just a few moments to talk about, as you develop these things, there's always been traditional challenges and barriers to CHP. In the area of just the electric utility interconnect, every utility is a little bit different, technically, also from a tariff-based basis, and these interconnections can take a lot of time and a lot of technical talent to make them happen. Economically, these are large commitments and investments. Typically, if you look at them from a simple payback standpoint, they have a long payback period. However, if you looked at them from a total life cycle standpoint, you realize that these are very effective solutions to people that have large energy needs that can be dealt with. Savings sometimes are difficult to document because of the long term, and the changes in tariffs and volatility of natural gas prices historically have made these things difficult to quantify moving forward. And of course, environmentally, these things represent new ignition sources. They are new regulations. The DEP is always trying to look for the best available control technologies, which means you're always consistently raising the bar on these type of technologies. So as you develop CHP, just traditionally moving forward, you find out that these things, it's a very active, but with some serious challenges to make them happen. But now came Sandy, and Sandy has somehow found a new impetus to develop CHP and distributed generation in general. From a marine energy and energetic standpoint, our experience during Superstorm Sandy was that our solar and landfill installations were fine. We basically suffered minimal physical damage at each of the sites. However, because the grid is needed to run those facilities, we were unable to operate, probably for up to 3 weeks in some areas. Our systems of CHP in Atlantic City, though, they fared much better. We manned them through the entire storm, kept them operating during the entire event. When the grid got very unstable down in Atlantic City during the height of the storm, we had a plan in place, along with our host customers, to turn into an island mode, and we were able to utilize several of our pieces of equipment there to make that happen. What this does is this proves out the capability of CHP and how critical it can be in withstanding events such as Superstorm Sandy. We were able to coordinate with our customers to load shed. We were able to create islands of reliability, all of which were very important. Because we developed a lot of the higher-end electrical systems in these facilities, we were able to design and build in flexibility into some of our designs. So we had options that we could actually run emergency generators, which we have there for life safety, alongside our cogen to provide even more reliability and flexibility to our customers. One of the other lessons we learned was after this storm. And what we found out is we rode through the storm fine, but after this storm, moving people and resources around our various facilities in the state was much more difficult than we ever anticipated. Trying to get some of our basic stuff to recover, trying to get people out of their houses, trying to get suppliers online, get suppliers' materials to us to get other things back online, we found to be very much more of a challenge than we had expected. So this is probably one of the ideas of the lessons we learned going forward, was not just getting through the storm, but also planning after the storm. In general, the role of distributed generation provides reduced stress on the grid. It does it in the high temperatures of the summertime through PJM. It also does it through events such as Superstorm Sandy. CHP also provides high efficiency because it uses not only better heat rates for making electrical energy, but also allows you to sync the thermal loads, therefore providing efficiencies that are traditionally much higher than a normal power plant. What we've learned from Superstorm Sandy is that it is a critical part and can be used as part of a program to protect critical assets and to ensure continued operation of those assets moving forward. A lot of the talk up here has been around policy, and I was trying to kind of provide a more granular level experience of what we saw through Superstorm Sandy. But as we step back and we're trying to develop more projects as we move forward in New Jersey and across the Mid-Atlantic, we ask ourselves some questions that I think the policymakers need to have to address. What is a critical asset? Hospitals, wastewater treatment plants, clearly these are all critical assets that should be kept online during the course of a major event such as Hurricane Sandy. But what about the next day, when a lot of your utility infrastructure is no longer there, and you need your gas stations, and you need your hardware stores, and you need your supply houses to get yourself back up and running? I call them the morning after assets. What do they need to get back online? Because clearly they're a great economic impact to keep us going. The concept of hardening an asset and making it more robust, what does that entail? Early part of my career was spent in the nuclear power industry, designing and developing nuclear power plants. This process, basically you go through it, they call it design criteria, where you document and list every single criteria, whether it be wind load, earthquake, rain, tornado, you name it, jets flying into buildings. If you're going to harden an asset, you have to walk down almost a similar exercise to figure out what it is you need to do for these facilities. How much redundancy do you need to build into the system? And how many multi-level operating scenarios do you want to think about? This is very important, especially when you start thinking about putting reliability back into older facilities, such as your more established hospitals or your more established wastewater treatment plants. These are not impossible. These are going to be cost adders, but I think CHP, as part of an overall program to make these things more hardened and more reliability, can be done, and it should be done. Finally, efficiency and environmental considerations. These are legitimate considerations and should be added into the program, but it's very important to understand that we can't let these things break the program, and that it has to make these things more structured and more reliable and more resilient moving forward. So that's the conclusion of my remarks. Thank you for your time.
Thank you, Stephen. You guys talked about CHP being important at hospitals, wastewater treatment plants, and nursing homes and such. What kind of cost is it for a typical facility there? How much capital investment is necessary? And what kind of incentives are needed to make it economically viable? And how big are the systems? Roy?
Yeah, I guess let me take the first shot at that. I think that the cost basically of installing traditional, what I'll call traditional combined heat and power, are pretty well understood, and typically vary between about $2,500 per megawatt to $3,500 per megawatt in New Jersey. What's much less well understood is the cost to make those systems grid independent, and the reason for that basically is that, you know, adding the capability to the generator to restart is a relatively minimal cost, and I'll suggest that's included in the numbers I just put out. However, it really depends on how that facility is wired as to what the costs are to bring the emergency circuits back to the CHP bus. Traditionally, hospitals, and they're a great example, will have, you know, up to 20, 30 distributed generators, diesel generators that currently provide backup service. What we realize now is that they do not have the ability to withstand a long-term outage. However, to transfer the emergency circuits that are currently now at potentially 20 or 30 different points within the hospital back to a central location is what's needed to make CHP be able to do that, plus additional switchgear to allow the appropriate what's called step loading on the CHP system. And I'll suggest that that number is highly variable. If I'm building a new hospital, I can incorporate that in my design and the incremental cost is little to nothing. However, as what we see in most scenarios when I'm retrofitting, it really is an unknown cost, and I'll suggest that it's probably vary somewhere between 0 to 50% of the project cost to make that facility grid independent. And just on the other point, I mean, we've seen in New Jersey, and the evidence is very clear. When we provide for traditional CHP, when we provide a subsidy in the area of 30%, that absolutely moves the market. When we do not provide a subsidy, there is zero movement in the market, and that gets back to, I think, a point that we've all made. You know, the benefits, there are externalities, as they're called, benefits to society, benefits to ratepayers, et cetera. You know, if we don't share those with the CHP developers, we're simply not going to get any development.
Mm-hmm. I think I heard you testify earlier this week that the current bill that several of you said is the way to go, the alternative energy portfolio standard, shouldn't include a mandate that all CHP facilities be so-called grid independent.
Well, and where we felt the disconnect is that, you know, we believe that the current programs and the proposed, you know, alternative compliance payment of portfolio standard, which is really proposed, so the current program is a straight grant program, which offers somewhere in the area of 30% of the CHP cost. That will absolutely move traditional CHP. Where it's low cost to make that grid independent, I think those facilities will do that because they do derive some benefit from it. However, to simply suggest that we take that 30% and we impose the requirement to make that grid independent simply won't work. 30% does not cover that additional potential 50% cost. So if you want to make it grid independent, and there's probably more societal benefits to that than there are to traditional CHP, I'm afraid we're going to have to pay for it. It's not going to be free.
Pam mentioned that it doesn't work for every facility. The Energy Master Plan, as someone mentioned, has a goal of 1,500 megawatts of CHP by 2020. Is that goal feasible? Are there enough facilities suitable to be converted to CHP?
I think, I mean, I don't know if I'm in the best position to answer that in terms of a market
Okay.
survey, but I think it goes back to the point I was making about, you know, if what we value is reliability, then we need to pay for that. And it could be using CHP gets you there, but it's not the low-hanging fruit. It's not the project that's going to happen by itself just because of the incentives currently available. So we could certainly have that much CHP out in the state of New Jersey. The point is, where is it going to be?
And then you said we need to prioritize. So, in the scheme of things, you know, you've talked. The panelists have talked about hospitals, wastewater treatment, prisons. Well, I guess nobody mentioned prisons, but I've heard that mentioned. From your guys' perspective, what should top the list?
I mean, I can take a shot at that because we've looked at hospitals. I mean, we think basically it's hospitals and prisons, you know, are key because you need to have health and safety for the general public. Okay, we believe water treatment and wastewater treatment facilities are also key. Again, health and safety of the general public. Will a CHP work perfectly? All those things. Hospitals usually, prisons usually, because you will usually have a good steady thermal and electric load at those type of facilities. Water treatment and wastewater treatment, there's a good central load, but you'll get a lot of peaking load during a storm like that. So you need to make sure that you have some peaking capability over and above just the basic CHP to keep that facility operational. So any kind of public policy you have that addresses a water treatment or wastewater treatment facility, you need to kind of expand that if you're going to look at the hardening and reliability of that piece.
That would drive up the financing of the project then, say at water treatment facilities, to have the peaking capability.
Right.
All right.
So Tom, can I just weigh in
Sure.
on, you know, a theme I'm hearing here about Black Start, and you know, there's this concern that we don't have enough money there to ensure the reliability we need from an island point of view, and I think that's right. I mean, I think the numbers that Gerard just gave you are correct in general, but when you're looking at major upgrades in order to bring that societal benefit, you need to speak about a different set of costs. To give an analogy, I guess, when you look at the regional transmission organization, so a PJM or the New England Power Pool or New York ISO, they value Black Start capability on a wholesale basis. They will pay under tariff for Black Start capability. So there's a recognition that system restoration is important. So I think when we're looking at these distributed generation cases, I think we need to look at that as well. We've all talked about the benefits of CHP, and everyone understands the environmental benefits. But I think if you're going to take it a step further on resiliency, you need to understand that there's huge benefits. If there's a place for people to go to in the event of an emergency, if you can avoid moving patients, and we saw a lot of unfortunate situations occur during Sandy of moving patients out of healthcare facilities, that is valuable. That societal benefit needs to be recognized, and it's probably going to need to be recognized in a different way than as a general CHP incentive that will bring more distributed generation, but not necessarily solve, if you will, that Black Start problem.
Sure.
Weigh in also, we talk about is there enough facilities to support the 1,500 megawatts, and hospitals being a great market to do that with. It has a 24-hour thermal and electric load. But you get to some hospitals that have been around for a long time, and they weren't built in one building. They've been built and been added onto, and then added onto, and then added onto. And it's one of the cost measures that they went through when they did that. They chose not to build a bigger substation or bring power in on one transformer. They chose just to bring another service into that extra building at the campus. I mean, you get to a hospital that has 10 electric services, and you're trying to plug in a 3 megawatt a piece of equipment. I say plug in, you don't just plug it in, but it's difficult, and there's cost associated with getting that facility, who has a great opportunity for CHP to make that economic. Without these incentives or additional incentives to be able to provide for those kinds of projects that are the right place to be, you know, these projects won't happen. So I believe that the market is there. Some of these projects will be a little more costly because of the specific situation at the facility, but I think we can get to it.
Okay. Several panelists seem to endorse the bill that came out of the Senate Energy Environment Committee this week for the alternative portfolio standard. There are benefits environmentally from doing CHP. They're cleaner than traditional conventional power plants. And some environmentalists suggest credits under an alternative portfolio standard should be reserved for only renewable energy projects and not be given to facilities that burn a fossil fuel. What do you folks say to that?
Let me take the first shot at that. So, I mean, I think if you look at options for, what's an efficient play in an urban environment, let me start there. CHP is a great efficiency play in an urban environment. It's hard to put wind turbines up. Solar is only going to be limited in urban environments. So clearly, from that perspective, I would argue that it has the same benefit. I wouldn't call it renewable for obvious reasons, but it has the same benefit that you're trying to accomplish in the sense that when you're producing simultaneously heat or cooling with electricity, you're making, you're getting the value, if you will, twice from that MMBTU of gas. There is clearly an efficiency benefit there. The incentive that it sends is to get more, to make a greater efficiency play. So in other words, if structured correctly and you're not robbing Peter to pay Paul, that is, you're not reducing megawatts to make steam or vice versa, but you're truly co-generating from that 1 MMBTU of fuel, then that is an efficiency play that is in many ways, from a policy point of view, similar to what you're trying to achieve with a renewable resource, and you can do it in an urban environment.
I'd like to just kind of add on that a little bit. The other thing you're also doing is you have central energy plants, and in traditional ways, coal used to be dispatching before natural gas. So if you're avoiding megawatts and you're avoiding some of that base load coal, you are actually saving some environment. Also, central coal plants transmit over long distances. You're avoiding those losses. So your efficiency is not only in what you generate there, but also what comes out of the generator to the end user. There's also an increased facility. I think by putting some type of RPS standard on all of those things helps incent people and helps the public good.
Okay. This morning on one of the panels, Dennis Wilson talked about solar being should grow even more dramatically in New Jersey and help make the grid more resilient. But it has the same problem as some CHP with the island concept. How much does that drive up the cost of solar, making that being able to turn on even if the rest of the grid is out?
I mean, none of our solar systems have black start capability, basically. We don't have battery storage that can basically get the inverters charged back up and kind of get them going again. So they were never designed to do that. So the solar systems that Marina Energy does strictly reduces the grid stress during the hot summer days. I heard Pam talk about one system that they put in. In my mind, at least as an engineer, the jury's still a little bit out on how effective that system is. I could see it coming down and being more effective over the next couple of years, but I'm not sure I'm ready to sign on personally onto that for being black start and that level of reliability yet.
Let me add here. It's not installed yet, so I don't want anybody to go look for it. It was recently procured, and it doesn't. And let me also be very clear: it doesn't have. The definition of black star is there is a certain number of circuits that could stay on in the event of a grid failure, but you have to be very selective about what circuits you would choose, and that's part of.
So there's a load shedding capability, or
exactly,
yeah.
exactly. But there have been, in terms of islanding capability, there have been battery backup systems and solar installed over the last 30 years. They were a bit of a headache in terms of maintaining them and costly, but they've worked, and the battery technology is getting better and better every day. So again, those solutions exist, and one of the points I was making about the 20,000 or so odd systems we've got up in the state of New Jersey is that you might consider throwing some storage at select systems to enhance their emergency power capabilities, but it's going to come with a cost. I think what that cost is, again, it depends on the specific electrical configuration of the facility. And the one thing you know in this industry is one size doesn't fit all. It's highly dependent on the project and the particulars of the infrastructure you find there.
Okay, I got a question from the audience for you, Gerard. What are the specific policy changes needed for proliferation of CHP, and what are the most significant impediments?
Well, clearly, you've heard us all basically talk about CHP and, money and subsidies we talk about, and I hate to sort of use those words sometimes. I rather suggest that it's a sharing of benefits. But clearly, we, over the past, I'll suggest 10 years, a lot of progress has been made on removing what were called barriers to the implementation of CHP. These barriers included things like very high standby charges, and that's an issue that we're currently at issue in New Jersey, and there's a rate case going on around that, so it's something that we're dealing with here.
Could you explain for the audience what standby charges are?
Sorry, a standby charge. So a combined heat and power system or a distributed generation system has, it's a mechanical piece of equipment. It needs to be taken down for maintenance, just like your car needs to be brought into the garage for oil changes. When it's down, you need to power the facility with the grid. And what the grid charges you for that standby service can vary very considerably. It's typically denominated in terms of dollars per kilowatt of capacity availability per month. And we've seen, restrictive impediments would be a standby charge, for example, that would charge you $10 per kilowatt per month just to be available. It's not necessarily a service that you're going to use every month. It's a service that but you do need to maintain the facility reliability. You do need it, and there's good synergies between the application of distributed generation and the grid. This has been a big barrier. That a $10 rate is sufficient to essentially kill a CHP project from an economic perspective. And we've seen this happen basically first in California, New York, Connecticut, Massachusetts, et cetera, and we're now dealing with this issue. And I'm not suggesting that our current standby charges are serious barriers. But they do need to reflect the true and fair cost of providing standby generation, and they also need to reflect some of the benefits to the system. And, as Jeff pointed out, we pay for that capability anyway. So, if somebody's going to provide distributed generation that enhances the ability of the grid to operate during normal conditions, and certainly island during grid outage conditions, then why would you charge a level for standby service that basically prevents that from being implemented? So standby charge is clearly a big one. Standard interconnection is another one that's sort of small. Right now we go to the individual utilities and you apply to have your system interconnected. You have to agree to meeting all their rules and regulations. Life safety is a major consideration for utility line workers. The technologies are well developed, well understood. In many states we have a standardized interconnection procedure, and part of those rules will also dictate what length of time a utility has to review a project. So this again is another potential barrier where if that length of time is open-ended, investors lose interest if it takes 6 months to get an answer from the utility on a relatively straightforward issue. In terms of, there are typical examples of barriers. In terms of the most important ones, I really think, and I don't mean to try and restate my points here, but I really think that a proper understanding of the benefits and a proper attribution of cost to the beneficiaries is absolutely the biggest impediment that we need to resolve right now so we can move forward. We're ready in terms of technology. And I think the other barriers are not necessarily that serious. It's really this issue of, the ROI is unacceptable to have, even with the current grant system, to have to make all systems grid independent and capable of restart, and particularly, as a couple of people have pointed out, the hospital is a great example. It's just that cost of making the facility itself grid independent can be onerous. So let's have this dialogue. Let's put the cards on the table. Let's understand who benefits, and let's apportion some costs and get moving here. I think that's the biggest issue.
Some of the impediments you mentioned involve your dealings with the electric utilities. These projects cut into their bottom line. How would you folks describe your relationship with utilities? Are they trying to impose these barriers to prevent you guys from moving forward and retain your customer base?
I'll give you, for me, it's been a little bit of both. There's been some positive interaction. A couple of examples are maybe special cases for private wires. When you're matching up thermal load on a campus, and it may be that there's some issues in the way with private wires, we've been able to work through that with utilities in a way that's made sense. Likewise, there's been other examples where there are critical load pockets for them, and they might encourage and help us to get distributed generation in the form of CHP into that area. And for them, that helps as well. Of course, on the flip side, as you point out, not to be too blunt, but if you're making your money by hanging conductors and a return on equity, mechanism every time you hang conductors sometimes are the way you want to go versus putting generation in. So I think it depends. For those that sell gas, certainly it's not a bad thing to sell more high-pressure gas, right? So I think it depends on what the situation is. But I will say in general, I've seen a trend where the utilities are coming around and understanding that there are instances, there are times, there are places where distributed generation makes sense, and if it's the right application, then they're supportive.
I'll just weigh in a little bit. Our experience has been varied also, but I think one of the things we talk about with standby is the fact that utilities, they put those initial wires there, and they want to earn on those wires, and they view that standby charge as kind of a way to kind of keep that ability to earn on those wires that they put in. And we kind of take away that ability for them to earn through that by delivering kilowatt hours through those wires. So they kind of come back, and they come back with these standby charges. These standby charges can be difficult at times. They're not huge, but they definitely can be difficult and challenging from an economic standpoint. And their tariffs, the tariffs can change very quickly, and how the tariffs treat a cogen can be detrimental from time to time. So just because you get the cogen in the beginning, you have to make sure that you stay on top of some of the changes that are coming down in the structure of how they're going to treat you.
You folks have talked today about prioritizing where these facilities should go. Should geographic location be a part of that consideration? Somebody this morning brought up the problem with capacity payments, especially in northern New Jersey, that add billions of dollars a year to utility bills.
Yes.
Yes?
Yes. Yes. I think it's back to the islanding. In many ways, it's a similar debate, right? I think where you put it, in my opening comments, I mentioned that in the old days, there were pool-planned facilities. That's exactly what you did. You figured out where generators made the most sense on the system. What happened post-deregulation is that generation was incentivized by things like, where can I put this generation close to transmission, close to natural gas pipelines, with low real property taxes? It was not a planning mechanism for where generation went. If you're trying to solve a reliability problem, you absolutely should figure out where do I have problems and target those areas, just like the debate we're having with islanding. There's times where it makes sense, and if you need it, it should be recognized and compensated.
We have some questions for specific panelists. For Bob Kudrick, What is different in the CHP market now than in 2009 when the Energy Master Plan first came out? I guess the biggest difference is Sandy.
Yeah, customers, that's top of mind as I started when I spoke earlier, was that customers are really see a value in having some sort of backup reliability. So customers who had projects on in their filing cabinets with dust on them often are re-looking at that because they see there's an advantage there. The other things that are different from back in 2008 and 9 is the abundance of natural gas and the lower value of that. As we get gas from across the Delaware River here out of Pennsylvania, we see gas prices have dropped dramatically from the 2008-2009 timeframe. The other part here that will keep this momentum going is the policy for some sort of incentives to make this happen. And if we get that right this time and get started and see a consistency in funding over time, not just a window that's open for a couple of months at a time, but it's just out there, and you know that there's going to be a market to bid into every couple of months or every 6 months. That would certainly keep this moving along. So I think it goes back to the question you asked before: can we get to 1,500? Yeah, I think we can. I think that a lot of the things have come together to kind of make all that happen now.
Even with the steep drop in natural gas prices, there hasn't been a whole lot of CHP development on the scale that the Energy Master Plan envisioned. Why not? The impediments that Roy talked about and other factors?
If I'll just start the discussion, and again, it goes back to sort of the theme that we have here, that the wave of the future is not technology development, it's policy development. There's no doubt in my mind that a significant impediment to the development of CHP has been policy inconsistency. And we don't have the right type of long-term signals, and as Bob sort of addressed in his remarks, we're very supportive of a portfolio standard. Not, it's the same thing, it's the same sum of money. It's pay as you go from a ratepayer perspective, but what it really is a long-term solution. It's a legislated solution, a long-term solution that sends the signals to the industry. It can take 2 to 3 years to, from concept to switch on of a system. You simply cannot develop that in a policy environment where things change on an annual best case and worst case, with funds, the retail margin fund, where we had a bunch of people apply, $60 million worth of CHP was on the books, and then the money was just taken to fill a tax hole. I mean, that not only kills, of course, those projects, but it absolutely kills the industry's enthusiasm. These are, there are other places to go. Most of us are stuck here to some degree, and I'm happy to be here, but the industry can pick up and move. And that's really been a problem for us here in New Jersey. We need those signals. We need the industry to understand that New Jersey is a long-term play, and then we'll achieve our goals. So policy inconsistency is a problem, a big problem.
I would add something here, Tom. Just in the lesson that we learned from the solar adventure a decade ago, I mean, it's the same conversation we had back then about what does that technology need to really grow, and it was, above all, certainty. Eventually that regulatory work got put into statute, but it required a long-term signal to the industry that there was going to be demand for the next 10 or 15 years. I think you could say something pretty identical with CHP and other technologies.
Bob, I think you wanted to jump in.
Yeah, I did. To jump on what Garut had said, we develop solar, and we know that we can put a solar system into a facility rather quickly. We're plugging into their, I say plug in, it's really not that easy. I don't really mean to diminish that, but we do plug into the facility, and we really don't care how the customer uses electric there. It's net metered. They can allow the electric to be pushed back into the grid and come back. When we go into a CHP, the development cycle is a long time. It's a year to 18 months, 2 years, maybe 3 years. You have to make sure that the energy that you make is going to be used at the site and it's never pushed back on the grid. And you're tying back into a customer's facility
to into their steam loop, heat loop, cooling loop. You have to be able to integrate all of that. So as we see with the market with solar, that you can put projects in relatively quickly in comparison to CHP, these take a lot more planning. So I believe there are a lot of people maybe in this room, people outside of here that are developing projects. We haven't seen that, but it's the development cycle that takes a long time. And I think that it'll be a different conversation next year in 2014 when we're here. If you're planning another one, I don't know if you're planning another one. We'll see a lot more projects being put into the ground.
Mm-hmm. This morning, Stephanie Brand talked about the high cost of solar, $5 billion over the next 20 years, and that's being borne by ratepayers. To get 1,500 megawatts of CHP built, what is the projected cost to ratepayers, and what are the credits going to cost? I mean, now the solar credits run about $140. It's not going to be that expensive, is it? Go ahead.
So I guess I think, no, it's not going to be that expensive. Combined heat and power at the current rates for solar is significantly cheaper. Clearly there's an objective here that we've invested in to reduce the cost of solar and bring that down, and if we can bring storage down into a reasonable level, that will be a great thing. But at this point, combined heat and power has a couple of advantages here that go back to this issue of the ratepayer and the cost to the ratepayer. So it's significantly cheaper, and I think if we were to create an SREC type program that were to make payments towards a CHP plant for a 10-year period, the actual cost of a REC that basically has a net present value of 30% of the cost of a CHP system would suggest we're somewhere in the area of $50. And there's an additional benefit, so the offset of transmission and distribution, because combined heat and power is a dispatchable system, and when we aggregate multiple combined heat and power systems, it can actually displace capacity as well as transmission and distribution. Those savings go towards reducing, that nets out against the $50. And we're still in the process of doing the cost-benefit analysis and understanding all of these issues, and this is outside of the externalities such as emission reductions, et cetera. But I believe that, yes, we need to see somewhere in the area of a $50 REC, for example, but the benefits that a significant amount of CHP on the grid can bring will bring ratepayer reductions that I believe will be pretty close to that number.
That's good news to hear. And I have another specific question to a panelist for Jeff Perry. How reliable is CHP, and how certain are we that CHP is going to be available?
So I assume the question is about reliable and availability in generating. Okay.
I guess that's what.
Yeah, I mean, I think in general, the availability factor of small-scale CHP is very high. I mean, the availability approaches much greater than 90% of the time. But it brings up an interesting point that we haven't talked about, which is, again, back to this black start capability, and why should we pay more for reliability? Can't you do it on the existing formula? One of the things, if you look back at some regulation that's happened over time, PERPA is a good example where we had examples of power purchase agreements given to generators with no requirement to be available, no requirement to have certain efficiency or guaranteed heat rates, for instance, on their equipment. There's no reason that a debate can't happen about availability. If you're truly going to use these facilities for islanding purposes, then put some availability criteria on them. But in general, I don't think that's going to trouble the DG community because the availability of these turbines, for instance, are very high.
I'm sorry. We have only about 5 minutes left. Is there anybody in the audience who wants to ask a question? Bill?
Thank you very much for your presentations. I sort of felt I was in a bit of a time warp because I was the lawyer for cogeneration companies back in the 1980s and 1990s. And the problems you're discussing are the same ones that my clients had, and we had to overcome those by tough negotiation. But the big thing that boosted these projects, and I was personally the attorney for more than 1,000 megawatts of cogeneration development in the state, was the leadership of the BPU in recognizing the importance of cogeneration for the society and the environment and the economy. And that led to the promotion of long-term power purchase agreements. Now, I think Mr. Foley mentioned a 10-year, $50 REC for CHP. Do you think that that could be the silver bullet that propels this industry once again?
A simple answer is yes. I think, you know, in those days when you guys, and thank you for it, but when you developed significant amount of CHP, that was, of course, the PERPA days where there was essentially a feed-in tariff. And so we do still have, despite all your good work, there's some negative connotations because a lot of those deals were struck at a time when the wholesale costs were very high. They subsequently dropped, and community ratepayers felt that they were sort of on the wrong end of that negotiation. So I think it's, you know, it's a very tough political issue. The alternative portfolio standard that has moved through, you know, out of committee in both the House and Senate is a vehicle to achieve essentially the same thing. You know, it's easier to talk about a portfolio standard these days than a feed-in tariff. But I think, you know, what we're, again, I think all clearly saying is that, you know, there are benefits to other than the developer owner of the system, and the beneficiaries need to contribute towards the development of these systems. And I think, would we all agree, you know, in whatever format, and $50 over per cert over 10 years, the current BPU program with recognition of islanding costs, either one essentially gets us over that hill.
Yeah, and I would agree. So it's a little different than the wholesale markets where, you know, you got merchant generators that are saying, I need a long-term power purchase agreement because I've got nothing other than day ahead or real-time prices, right? In the case of distributed generation, you in effect have a contract. You're building it with the customer. The difference is, if you look at the APSs I'm calling it APS, which is a program in another state, but if you look at that type of mechanism, that certainty is going to at least guarantee you a better financing package. And that's going to be very important. Oftentimes that will make the difference, you know, in getting a project built, as you know, is the financing package. And if you can get an infrastructure fund to see a 20-year, you know, revenue stream, absolutely, it's absolutely going to help.
I think we have another question over here.
What are some examples in other areas outside of New Jersey of successes in programs? We've talked about, you know, New Jersey mostly today, but you know, outside of the state, any good examples out there?
I know, Jeff, I'd like you to talk about Massachusetts because that's possibly the leading end, but let me just throw a couple out first. So we have, California's had a long-standing program and has, you know, significantly more combined heat and power installed. And it's really done that through a straightforward grant program with certain requirements on efficiency and emissions. New York is a very well-developed industry, again, based on, and you'll find all of these are going to support in the 30 to 40% area the cost of installing these systems. So it seems to be a fairly simple metric. I think it's fairly well understood, and it is, you know, I think we started out saying this isn't necessarily for everybody, but in a state like New Jersey, where we have enormous capacity costs, we have significant grid reliability issues on a working grid, and we clearly have been, you know, really reminded how bad things can get when the grid goes down, that it's worth our while investing, and of course it addresses our high energy costs. So, you know, that's where you're going to see it. You're going to see it in high energy cost states, essentially where they provide a support, and Massachusetts, and I'll hand over to Jeff maybe on that, has been very progressive in their recent developments.
Yeah, I think with Massachusetts, it's, the program is administered by the Division of Energy Resources, and the DOER in Massachusetts is the energy policy arm for the state. And in fact, when I mentioned APS, that's actually the Massachusetts program's alternative portfolio standard. So they do have an RPS program, which is very similar to many states, and they have an APS. And the APS is aimed, primarily at cogeneration. And it's been an effective program. It's been a program that the DOER has nurtured along. They're proud of that program, and I think it's a good model for us in New Jersey to take a peek at. It may not be the perfect model, but I think it's got some good attributes, and it's certainly a starting place.
How much CHP has resulted from it in Massachusetts?
I don't have the numbers, Tom, in front of me, but it's been successful. It's undersubscribed right now, which is a good thing. It's a good target for all of us, but it has had success.
All right, it's 3 o'clock. We promised to get people out here after 3 o'clock. I want to thank the panelists who did a fabulous job.
We hope you enjoyed this program. For more information, visit njspotlight.com. We produced this program in the studios of Lubetkin Global Communications in Cherry Hill, New Jersey, on the web at lubetkin.net. For everyone at NJ Spotlight, this is Steve Lubetkin. Thank you for joining us, and take good care. NJ Spotlight, where issues matter.